Welcome, good morning, afternoon, wherever in the country, in the world you are. We're here today to talk about the DJI L3, which was announced just 10 days ago. And there are so many questions out there. We thought about putting out a blog post, and we probably will eventually too, but so many people wanted to have a more, that I've had, basic conversations with, wanted to have a little bit more live Q&A where we can go deep into the details of it. So over the next probably 45 minutes or so, we're going to do a real deep dive into what we know about the L3, what we don't yet, including a couple of things. We'll go real deep into the technical specifications of the L3, and more importantly, what the tech specs actually mean for land surveyors. Those of you that know Aerotas, that know me, know that our focus is specifically on land surveyors, and DJI serves a whole bunch of different industries. So if it's something that only applies to, public safety, for example, or firefighters, that's not as relevant to us. We're talking all about exactly what this stuff will mean on the ground for land surveyors. We are also going to put together how the L3 compares to other drones on the market, both other DJI drones, the other previous LiDAR sensors, if you have an L1 and an L2 and now are thinking about an L3, as well as the other drones, all of the other LiDAR sensors. How does the L3 stack up in that market as well? And of course, the uncomfortable parts and the weird parts. So I'm going to give an update on the regulatory environment around DJI, all of the rules, all of the regulations, what you can, what you can't, as well as making a few predictions of where I think some of that stuff is going to play out, but we'll talk about it. And then we can close with, when does it make sense to actually buy an L3? Who is this right for? Who is it not? And then give you some more links for that. As a brief reminder, if you're on this call, you probably know about Aerotas already. If you're watching this later on a recorded version, maybe you don't. But we have been around for 11 years now doing drone data processing for surveyors, where you fly a drone, including the L3 when it comes out, and other non-DJI LiDAR sensors and everything, and we process the data. And the other thing that you've probably heard with us is we have a different company objective than a lot of businesses. Our goal is not to make you spend as much money as humanly possible. In fact, quite the opposite. We want to help you build a drone program that saves time, costs less, and improves deliverables, right? This is the promise of technology: better, faster, cheaper. It is possible to have all three things at once. And if your drone program isn't doing all of that, it's not working. It's about finding balance between all of those things. And quite frankly, getting a good LiDAR system in general, whether that's DJI or otherwise, should be able to get you things that are better, faster, and cheaper. And the only way to do that is to find balance with all of this stuff. You need to find balance between accuracy, efficiency, speed, reliability, cost. It's always hard to find balance in things. People want to say, I want the best data possible in the shortest amount of time, but then they don't have budget for it. Or if they try and go super cheap, I don't want to spend more money than I possibly have to, then their accuracy suffers or it takes too long. And my perspective is not that of a research program. As much as I love the technology, it's not just about using the best technology. It's about what makes sense for business. And in the real world, you do have to balance budget, time constraints, operational constraints, so many different constraints, and finding balance between all of that is really, really important. And that leads us to the end goal, which is, of course, to get a map. As much as I love LiDAR technology, I love both L1 and L2, L3. I love non-DJI lasers. They're literally flying robots with lasers strapped on them. They are awesome. It's important to take a step back and realize the end goal is not to use the coolest technology out there. The end goal is to get a good map, a map that is on time, that is on budget, that is the accuracy that is promised or better, that actually gets people the deliverables that they need. Well, there we go. Just making sure that that doesn't work. And of course, because this is an Aerotas presentation, the best way to do that is to work with Aerotas. To work with Aerotas to get the best photogrammetry, the best LiDAR mapping, the best final maps. We work with hundreds of surveyors all throughout the United States and beyond to actually help people get the best out of whatever hardware system you are using. We will help you get the best data possible at a budget that makes sense and get you that promise, which is better, faster, cheaper technology. All right. So with all that out of the way, let's actually dive into the technical analysis. Like I said, we're going to start with a deep dive into the tech specs and what they mean. And for this, I will say there is a Q&A section here. Please ask this. So we're going to start by going real deep into some of these specs, what they mean. If there's anything you're unsure of, or if you want to learn more about the tech specs, drop the questions in there. I will do my best to answer as many of them live as I possibly can. So that'll be there. So the L3 LiDAR sensor. Let's start with the high-level things, what DJI is publishing. The L3, from a very high level, it is the successor. It is the third version in their LiDAR line. The first one, the L1, was released about 4 years ago now, I want to say. I think it was 2021. And it received mixed reviews. A lot of people loved it because it was by far the most affordable way into a mapping-capable LiDAR system, but it was not the world's greatest technology. The L2 improved upon that a bunch, and the L3 is the next variant. And I'll start with the kind of high-end conclusion. The tech specs on this are unbelievably good. Very, very high-quality tech specs. So let's jump into it. The first one that they advertise that few people understand the implications of is it has a 1535 nanometer laser that is a class 1 safety laser. So what does that actually mean? Well, it's a different laser wavelength, and the real takeaway from this different laser wavelength is that it's more powerful and it has a longer range. The reason other LiDAR sensors don't use this is because it is typically a much more expensive architecture. And I say other LiDAR sensors. There are other LiDAR sensors that use this. High-end Regal systems, for example, like a Regal Vux 1, that system will also use a comparable laser. There's 1550 nanometers in wavelength. It is generally considered to be superior, but it is quite a bit more expensive typically, which is why we don't see it that much. Part of the reason it has more range is because the biggest limiting factor with laser range is how much power you can safely put into it before it becomes dangerous to humans with their eyes. This particular wavelength cannot penetrate through the eye nearly as well, so they could put a lot more power into the laser and actually get better range off of it. So better range, we'll go into the detailed tech specs in a little bit, but much more range, lower beam divergence, which means that there's actually considerably better horizontal mapping capability, but that's one of the top level tech specs. Another real high level tech spec that is discussed a lot on their website has been that it has dual 100 megapixel mapping cameras. So quite frankly, I'm already noticing a typo on my presentation. That's what you get when you put together a presentation too quick. Dual mapping cameras, you can see right here, where is it? On the bottom, it has these two cameras right here that are both quoted as 100 megapixel cameras with a micro four thirds sensor on top of it. Quite frankly, that's overselling it. I've dug into the tech specs with a relatively small-ish micro four thirds sensor. Don't get me wrong, these are really, really good mapping cameras, but in the real world, I think there's some tricks going on back there that these are not actually 100 megapixel cameras. They are actually going to be much more comparable to 25 megapixel cameras. That there are some tricks that might be using what's called a quad Bayer filter. We're not 100% sure of that. And even if it were a true 100 megapixel sensor, which I doubt, the actual image sensor itself, being a 4/3 inch sensor, would have so much noise. There are just some limits of the physics and optics behind it, meaning that it wouldn't make sense to use that much data. It would just make your computer and photogrammetry engine take forever to process multiple 100 megapixel images. So in the real world, this is equivalent to two 25 megapixel cameras. That is what it is going to be equivalent to. Now, to be clear, that is quite a bit better than the previous generation. That's, 225, or call it 150 megapixel camera almost, is one way to think about it in terms of the amount of data that it's getting. Still very, very good, probably a little bit oversold. This isn't going to compete in that sense with like $100,000 phase one, like true photogrammetry, true 100 megapixel full frame image sensor. So very, very, very good mapping cameras, not actually 100 megapixels. Here are a couple of more stats that are on here. An effective range of 950 meters. I will apologize. Even though this is a surveying presentation to surveyors, I normally like to speak in feet and hundreds of feet and tenths of feet. but this is all engineering specs. So we're going to be living in the world of centimeters and meters today, even though that's not what surveyors do. So effective range of 950 meters at 10% reflectivity. That is much, much, much higher than previous ones. What this translates to is a real world maximum of 500 meters above ground flying, which for those of you in the United States know that that is virtually illegal in virtually all circumstances. All this means is that you fly at 400 feet now. You can cover more ground, right? Flying at 400 feet, it has better range. Particularly, this class of laser has better ability on what might be viewed as shiny surfaces, like fresh asphalt is sometimes hard for the L2 to pick up, or for other previous laser classes. This one is going to be much better range. You can fly higher and still get very, very good accuracy. Another top level tech spec of this sensor, max return rate of 2 million pulses per second, so 2 megahertz. This is another one that is just marketing fluff. 2 million pulses per second just makes your points cloud enormous and does not add any material information. Until we actually get our hands on it, I don't know what we will recommend as the pulse rate that you will want to set, but probably somewhere in the 100,000 pulses per second to maybe a couple hundred, maybe up to 500,000 pulses per second. 2 million, that's like a top line marketing thing. Sometimes it bugs me. Yes, it's capable of doing 2 million pulses per second. You're never going to want it. This is not going to be a material difference over previous generations. The pulse rate is just not that big. Another really interesting tech spec on this is it flies on the DJI M400 platform only. It is not compatible with any other airframe. That means it's not compatible with previous DJI generations, the M300 or M350, and there is no known or practical way to get this LiDAR sensor flying on any non-DJI airframe. The reason for this is because it is about the sensor itself, the L3, is about 50% bigger and about twice as power hungry as the previous sensor, the L2. So if you stuck this on an M350, it wouldn't fly for quite as much time. It needs much more power. So DJI just made the setting. Maybe they're trying to push people to buy the M400 more because it's a newer generation drone. M400 is a great drone. It's a little bit bigger. The only knock I have on this is that it would be really nice if the L3 could fly on the previous generation actual drone hardware, but it can't. It's the M400 only. The M400 is the successor to the M300, M350, a little bit bigger, a little bit more powerful, a little bit longer flight time. But as I think I'll get into this a little bit later, one thing that DJI has always done really well is being cost effective. The M400 is, despite being bigger and bigger batteries and all of that, is not more expensive. It's not materially more expensive than the M300 or M350. Of course, you still would have to buy a new one to replace it or anything like that. But right now, just so you're aware, L3 is M400 platform only. All right. Let's keep going and digging through this. Additional tech specs on this new laser. 16 returns max per pulse. When it sends out a pulse, it can receive 16 total returns. This is likely overkill for virtually all projects. Again, we'll know a lot more when we test it. There are probably some vegetation scenarios where you might need 16. I would recommend, it looks like setting it to an 8 return setting will probably be the Goldilocks zone for most settings. So 16 is overkill. It's a good option to have in case you need it, but probably too much. 8 is going to be plenty. For those of you that are aware, the previous generation, the L2, gave 5 returns max, which is very good for a lot of vegetation penetration capabilities. And the L1 only had 3, which was a little bit limited. The L2 is much, much better. This going up to 16 has hit the point where, quite frankly, very few people and very few projects will ever really need that 16 returns. But that's something that you have if you need it. All right, next up, this is where we're going to start getting a little bit more scientific. Beam divergence of 0.15 mrads. That stands for milliradians. So a milliradian is a thousandth of a radian. A radian is a measure of angle. You don't actually need to know the footprint, like the details of this, but what it means is that it has a smaller beam footprint. One of the easiest ways to think about it, when a laser shines down, it's not actually like a perfect infinitely narrow point. It does have some bit of beam divergence. It's like a cone that goes down. The further you are, the higher up you are in the sky, the larger that beam footprint. If you can make it smaller, that beam footprint, which means a narrower beam as measured by lower beam divergence, what that means, you have a better ability to recognize horizontal features. This is one of those things that actually is going to matter quite a bit. It's one of the meaningful improvements, even though it doesn't really, they haven't been marketing this as much. They advertise the 2 million pulses per second and, you know, the 1,000-meter range, like a kilometer range. But this is what's actually going to make a lot of difference for surveyors. When you have at 100 meters above ground, that would be 300 feet above ground, a 3-centimeter beam footprint, that means you're going to get much sharper definition of things like curb lines and gutter lines, and the ability to very cleanly draft sharp curbs and gutters and other sharp built up features with a 3-centimeter-ish resolution. So yeah, definitely sub-10th horizontal feature recognition, even at 300 feet above ground. Once again, what this really means in practice, you can just fly way higher before. You could have gotten 3-centimeter spot size with an L2 sensor. You would just have to fly a lot lower. And in fact, that's what if you've ever worked with our flight operations team, our mission planning team, a lot of times you might ask for, oh, I have an L2, what should I fly? It's like, yeah, probably fly that site at 150 feet to make sure that you get really good feature recognition on hardscape. Now, you can get that same feature recognition from a much higher altitude, 300, 400 feet above ground. You can cover way more area in way less time, saving a lot of time in the field, which is really good. All right, we got some questions. Fantastic. Is the 3-centimeter the beam footprint at nadir or at the outside edge of the swath? Great question. That's going to be at nadir. So 3-centimeter is when it's looking straight down. As the beam does tilt up, it will increase. Now, some of this is going to come into point cloud processing and other mission planning too, because obviously the beam works best when pointing right down, but the drone flies with multiple swaths and there will be differing overlap recommendations. Our recommendation when it comes to LiDAR overlap in the past has always been on the higher side of industry average. That's our recommendation, to make sure that every point is covered by multiple swaths. And that way, this is where, again, the skill of your actual LiDAR technician, like the LiDAR technicians at Aerotas, can actually filter through the point cloud to make sure you get the best data when we filter it out. So 3 centimeters is at nadir, and there you go. L2 divergence was asked, what's the L2 divergence? I've got a chart coming up that'll compare divergence between the L1, L2, L3, but this is, the L2 divergence was a little bit different because it didn't have a circular shaped laser. It was actually an oval shaped laser. So the L2's divergence was about 33% worse in horizontal and almost, I want to say like 200% worse, like quite a bit worse in the vertical, but because it was an oval one. We're talking about the TrueView sensors comparison to other sensors. I got a lot of those comparison tables coming up where we will compare it specifically with some of the TrueView sensors and the Regal sensors and some other things like that. Is smaller beam divergence truly better? Doesn't a smaller beam footprint make it harder to collect multiple returns in vegetated areas? Technically, that is true, and that is one of the only potential trade-offs here. So in vegetated areas, sometimes you want a larger beam because that can better find the quote-unquote gaps in the leaves. My estimation is that if you can counter that by basically cranking up the point density. So that's where you want, in vegetated areas, you might want to go with 8 returns and a 500,000 point per second level, so that even with the smaller beam divergence, you still get very good vegetation penetration. That's going to come down to mission planning. Quite frankly, this on an overall level is very likely to be better at vegetation penetration if you get all of the mission planning parameters correct. We're going to be working on that once we actually get our hands on this. I should point out, if I didn't mention it earlier, as of this presentation, nobody in the United States has their hands on this sensor, and no one has a firm ship date or anything like that. We'll get to that. I'll give you all more information there, but there's going to be some where we've just got to start testing this in the real world to figure out those right recommendations. And in fact, for anyone that has worked with Aerotas, for all of our clients, we do mission planning for free. If you want mission planning of how high to fly, what the right overlap is, we have put so much research and testing into making sure that our mission planning takes into account all of these factors: elevation changes, vegetation type, operational considerations, GPS quality, GNet, like all of that stuff matters when we put together a mission plan for somebody. And so we'll be doing all of the testing to make sure that when we say, yeah, fly with 50% overlap, that's based off of dozens or hundreds of tests to make sure that the overlap is the Goldilocks zone for your mission. All right, moving on with some of these tech specs. Total system accuracy of 4 centimeters vertical and 5 centimeters horizontal. This is a 1 centimeter improvement over the previous generation L2 of the total system accuracy. The biggest benefit is not that this is a major accuracy bump, it's that it's achievable for larger projects and higher altitudes. And the main reason we're not seeing a larger bump despite a more powerful laser, smaller beam divergence, and all of that good stuff is that the limitation for accuracy is typically not the LiDAR sensor itself. It's limited by some of the fundamental physics of the GNSS system and the IMU that actually powers it. And what measure of accuracy is that? Yes, that is an RMSE error accuracy statement of 4 centimeters vertical, 5 horizontal. I have not tested that yet. Again, we don't have the sensor, but I actually believe that, right? And the reason is we've tested this a lot. That kind of like 4 to 5 centimeter range is about the upper limit of what you can get with a moving aerial real world system that relies primarily on GNSS and IMU and photogrammetry and LiDAR. The bottleneck is not the laser sensor itself. The laser sensor itself is absolutely sub-centimeter accurate, right? These lasers are unbelievably powerful. And it's one of the things that I actually knock a lot of the, like, I don't like about a lot of these other companies. They'll say, oh, our LiDAR sensor is accurate to 7 millimeters or, 10 millimeters, sub-centimeter accuracy. Yes, the laser itself is, but we don't really care about that. We care about the total system accuracy. When you're actually creating a map, what's the total system accuracy there? And the main limiting factor is going to be the IMU and the GNSS. And there are fundamental physics around GNSS and GPS systems that really don't let you get much better than that without extremely exotic forms of additional technology that aren't mainstream yet. So I do actually believe these numbers. Whether you can get that at 200 feet above ground, 300, 400, all of the above, that remains to be seen, but the specs lead me to believe that you should be able to get this 4 or 5 centimeter accuracy at 300 or 400 feet above ground with this sensor reliably point over point. So that's another, that's actually a very good stat. I'm happy to see that one. Couple other things. The LiDAR field of view is 80 degrees, a larger LiDAR field of view than the previous sensors. The previous one was 70 degrees, which was fine, but larger field of view means that you get a little bit more data, a little bit more coverage, a little bit more scan angle with which you can go, you can potentially go underneath vegetation, underneath eaves, things like that. Little better data overall, slightly better coverage, slightly better overlap. Great metric, but wasn't the bottleneck previously, but should be another just kind of minor improvement. A different improvement that we really like, thanks to those dual cameras, those 2 cameras are both pointed slightly out, they're slightly off nadir, and that gives it a 107 degree field of view, with the prior cameras, these single cameras, I think were 84 degrees. I have that in a spec sheet a little bit later on. So this actually gives much better photogrammetry coverage and makes it much nicer for what Aerotas preferred workflow is, which is a blended LiDAR and photogrammetry workflow. We really like blended LiDAR photogrammetry workflows because photogrammetry makes it much easier for drafting 2D features and things like hardscape, parking lots, finding manholes, utilities, utility access panels. That is all so much easier to do in a photogrammetric world, getting high precision ortho photos, so much easier with photogrammetry. This allows for an improved blended simultaneous LiDAR photogrammetry workflow. The L2 was already one of our favorites because it could fly photogrammetry and LiDAR capable missions simultaneously. This now has wider field of views in both, which once again means that it just makes it easier to get photogrammetry and LiDAR at the same time with reasonable overlaps and cover the field. So we really, really like that. Happy there. Is the IMU and the sensor are on the platform. The core IMU for the L3 and all LiDAR units is going to be in the sensor itself. The platform, the actual M300, M400, also has an IMU. It requires both IMUs to do the proper lever arm offsets because the drone is going to be kicking and moving. And you know what? I can show you because I have my L2 sensor right here actually as well. So the drone is going to be moving. The actual camera sensor itself is going to be moving. You actually need software to create the lever arm offsets and offset all of that at a pulse rate of a couple 100,000 times a second. So there are multiple IMUs in this system. The most important one is actually going to be on the in the LiDAR system itself. Has the auto calibration time increased relative to the L2? That's a great question. I have absolutely no idea. I have pored over every technical documentation I have found on this. I do not know what the calibration time is. So we'll have to wait until we actually get our hands on one and can test it in the field to know a little bit more. So those are some of the high level tech specs. Let's just confirm that, let's go from there to what are some of the real world benefits. Number one, as much as it's cool to say, yeah, this has a 1535 nanometer laser, that's not a real world benefit. A real world benefit is cover more ground per flight. More laser power, larger field of view for both LiDAR and photogrammetry. Both of those let you cover way more ground per flight. It will allow us to probably recommend 400-foot flights for virtually all scenarios. That's a really good thing. You fly higher, that means you cover more ground. You can cover more ground much faster. It often means less overall data without sacrificing accuracy, which means it's easier and faster to process, gets you better data. Larger swaths, it's much better overall. This beam divergence means better definition of 2D features. I'm sure my drafting team over here, everyone that works on drafting in the point cloud is going to be really, really happy to get sharper definition of curb and gutters, but that definitely needs real world testing. And accuracy overall should be slightly improved. Now, granted, if you were using the right procedures with the L2 or with other non-DJI systems, the total real world accuracy was already about at that 5 centimeter, about that 1/10 of a foot level is your real world RMSE accuracy. It just makes it, you can get that same accuracy, that same sub 1/10 of a foot accuracy at higher altitudes faster and more easily. So major benefits there for us working in survey. Accuracy is always table stakes, right? Like we don't work with projects that say like, oh, it's off by a foot or 2 feet. That's, absolutely disastrously bad by our perspective. It's always about accuracy. That just, you have to get accuracy right before you can move on to the rest of the operational considerations. This just makes it easier to get accuracy over larger project sites and faster. So that's really wonderful. And it's, again, going back, that's the technology of it's better, faster, cheaper, and we really like that. All right, we got a handful of questions about how do these different stats compare of the L3 versus alternatives. Let's jump into an extremely overwhelming table. Obviously, there are 3 generations, L1, L2, L3. This is what they look like. You can see they have gotten progressively bigger, progressively better, and more cameras. And I always like to point out the different color. That is because it is indeed a different wavelength of light that has to go through the sensor, which makes it a different color for us too. So here are your tech specs. And don't worry, we will send all of this out and we will publish this online later so that you can review all of this in detail. But let's go through it just at a high level pretty quick. L1, L2 were both that older 905 nanometer. This is a 1535 nanometer system. It uses a little bit more than twice as much power. It uses an average power of 64 watts, which is part of why it needs a bigger system. And it weighs 1,600 grams, 1.6 kilograms. That's, oh boy, my metric mental math conversions aren't great. Maybe 3-ish pounds. Someone will have a calculator and we'll figure it out. Here is your beam divergence, horizontal and vertical. This is specifically all normalized to an MRAD measure and what is called a, what is this? Full half width measure. I forget exactly what this stands for. There are numerous ways to measure beam divergence in degrees, in MRADs, FHWM, 1/E, 1/E squared. There are different ways to measure it. These have all been calculated to be normalized to the same thing. So you have to take what's on other manufacturers or other DJI spec sheets and normalize it. And what you can see here, your L1 was good horizontal, big vertical. That's why we saw a lot of vertical feature noise, or horizontal feature noise in the L1. L2 was much better, but it was still 0.2 vertical, 0.2 horizontal, 0.6, because it is an elliptically shaped beam footprint. The different laser now has a circular beam footprint. So even though it's not that much better in the horizontal side, from a vertical perspective, it is quite a bit improved here. The other thing, your range at 10 or 20% reflectivity, because not everyone reports standards exactly the same way, goes from 190 meters, 250 to the L2, and then 950 for the L3. So very, very improved range. Your maximum return rate went from 1,200 to 2 million. Again, you'll never use that. Returns went up to 16, probably overkill. 8 is going to likely be the recommended one for most surveyors. Total system accuracy, 1 centimeter improved. And they say it's a slightly lower range, but we're still talking 300 to 400 feet above ground, so that's great. Larger field of view. Once again, we've got more improvements in the IMU accuracy as well, stated IMU accuracy. That's good as long as it contributes to horizontal and to total system accuracy. That's what we really care about. Here's your camera resolution. You do go from 20 megapixels worth of camera sensor on the drone to 200, but the camera sensor size is still a 4/3. It's a micro 4/3 image sensor, and that's where the physics actually kind of restrain it. Like there are limits. You can make a 1 billion megapixel image sensor on there, but if you still have a 4/3 actual plate that receives the optics and your lens is the same, it doesn't get you any better feature definition or feature recognition. That's part of the reason, like some of those, why I think that those dual 100 megapixel cameras are probably nonsense. It's actually about 25. So this is your generations of DJI sensors. Now let's start comparing it to your non-DJI alternatives. But first, we have to take a second to explain how non-DJI alternatives work, because this gets pretty complicated. And we have somewhat. I will say, if anyone does have any questions, please click. You can put it in the Q&A tool by clicking the, I think it's the 9 dots meeting tools. Maybe it's the same for you guys. And dumping it in the Q&A session there. That would be fantastic. That's where I'm watching, and I will be answering all of those questions. All right, so let's talk about the non-DJI ecosystem. First of all, it's way more complicated. That's because you typically have to mix a bunch of different components to get a full system. First, you have to get an actual LiDAR sensor. There are very few companies that actually make the laser sensors themselves. This is the laser, right? That is Regal, Velodyne, Livox, and Hesai are both the most common ones. For those of you that actually know this in detail, Livox is actually more or less a subsidiary of DJI. They aren't strictly, they are technically a separate company, but the way that company interactions work in China is a little bit unique. The Livox and Hesai are both Chinese company. Livox is effectively what makes the sensors for DJI. Some of them, like the Livox Avia, they sell to other firms. Right now, the one that's in the L3 does not appear to be listed or for sale otherwise, but Livox and Hesai are the Chinese companies. Regal and Velodyne are the two most common actual LiDAR sensors, LiDAR laser makers themselves. But These are just the laser. They need to be integrated into a payload. And that's where other companies that are what we would call the payload integrators come in. This is where things like if you buy a system from GeoQ Group or Rock Robotic, those are two, or YellowScan. I didn't put YellowScan on here, but I absolutely should. YellowScan, GeoQ Group, Rock Robotic, all of those use LiDAR sensors made by someone else. I'll use GeoQ Group as an example because I actually really like them. Their accuracy is great. Their professionalism is great. Their systems are extraordinarily expensive, but I cannot knock the quality of their work. And they're also really transparent about which sensor they use. This is based on a Regal Minivux, a Regal Vux, or something like that. Rock Robotic, a little less so. Some of them say Hesai. Some of them won't actually say what laser sensor they actually use. But that's how non-DJI systems work. You have the laser sensor, often bundled, sometimes bundled with an IMU, sometimes bundled with the camera. It's put together with a payload integrator, and then the payload integrator also is typically the one that has to put it back onto an airframe somewhere. And that's where, well, a lot of these actually still go on DJI drones, and some of them will then go on other drones like Inspired Flight, Free Fly, Harris Micro Drones. To be clear, this is not a comprehensive list. Yes, there are absolutely other systems out there that do this. We can go, not a comprehensive list. There are other systems out there. My goal is not to explain the entirety there. We had a comment here that sub 5 centimeters is actually sub 0.2 feet, 1.9, not sub 1. Is that true? What is 5 centimeters in feet? 5 centimeters, yes, that is correct. That is 1600ths. So there you go. A 5 centimeter accuracy would indeed be 1600ths. And again, this is my problem when I go back and forth from feet to inches. We'll have to do some real world testing, and this probably indicates to me that once again, photogrammetry will probably remain the superior way to draft horizontal features in particular, and on hardscape, because photogrammetry can reliably get sub-tenth of a foot accuracy. All right, so jumping back into this. This is your DJI, your non-DJI ecosystem. Even making comparisons here is really, really hard because the sensors itself will have some limitations, and then those limitations change once you integrate it with a full payload and a full airframe. So the exact same Regal sensor might be better if GeoQ does it than if LiDAR USA does it, depending on their implementation, depending on the IMU they put on, depending on their GNSS post-processing and all of that good stuff. You add it to a different payload, it has different ease of use. It's hard to compare them, but I'm going to do my best using a couple of things. We're going to start with the DJI L3. We're also going to compare it to two of what are considered the more state-of-the-art-ish systems. One is going to be this one. This is the Regal Minivux sensor. So this is a sensor that is used in a lot of payloads by companies like YellowScan and GeoQ Group. Will use the Regal Minivux. It's UAV. It is designed for this sort of system. Regal is considered to be top of the line when it comes to quality, also top of the line when it comes to price, but that's what we're going to talk about very soon. We'll also do Regal higher end level. So the Regal Minivux is approximately a 900 nanometer laser as well. And the Regal Vux is more comparable with the L3 at a 1550 nanometer laser. And I also threw in here partly because I couldn't find what the underlying sensor was. This is the reasonably newly announced the Rock LiDAR Ultra. It's called, that is also a 1500 nanometer class laser. So let's go ahead and jump into the tech specs here and just talk about it. So the only one on here, the Regal Minivux, is the only 905 nanometer, which is like, I don't want to say the older generation because it's still a very, very, very good system. This is a high quality, like the Minivux is a very high quality sensor. That doesn't mean it's not without limitations, but very high quality. So let me just highlight a couple of things on this. First of all, I like highlighting the weight. The Regal Vux 1 UAV, which is probably the most comparable to the L3 right now, it weighs over twice as much. Its beam divergence, when you actually calculate it, is actually a little bit higher than the L3. Its stated range is a little bit lower. Similar max returns rates, that doesn't really particularly matter. Same horizontal and vertical system accuracy. I had to put an asterisk on there because The systems themselves, they try and say, like, this is another one where Regal itself on their specifications don't have a total system accuracy because they sell the laser without the IMU. They sell it just as the laser scanner and rely on a system integrator to do it. However, high quality system integrators like YellowScan, like GeoQ Group, they're very high quality, typically report 3 to 5 centimeters as the total system accuracy again. So good data there. They have much larger field of view. The Regal Vux 1, for example, can do a full 360, which of course is completely useless. You would narrow it using software to what you actually need. Probably 90 degrees is about the highest you would ever do, maybe 120 in some circumstances, but the point is you have it pretty high. The real difference comes in the price here too. So most of these systems, let's now talk about price because that actually is really what matters. Or not really what matters, but that's the biggest differentiator with DJI. There are two big differentiators. The DJI L3 final pricing is not formal. There are some places that say it's in the $15,000 to $17,000 range, but quite frankly, we're not 100% sure. They're not taking firm orders yet. So if you do find places that say, there are plenty of websites now that'll say, oh, MSRP of this number. Those aren't firm numbers. Tariffs can change, import duties. We're not 100% sure, but this is going to be a good order of magnitude. And what you will see is that the Regal sensors and even the Rock Ultra sensor, once it's fully integrated, is way, 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 way more. In the real world, a DJI L3 with everything you need, including the M400 platform, is likely to be in the $40,000 to $45,000 range, all in, everything. Whereas Mini Vux and Vux 1 UAVs that have much higher payload integration costs, much higher sensor costs, I mean, there is no way you can get a Regal-based sensor system, full system, for anything less than $100,000, and typically they are in the $200,000 to $500,000 system range for much higher, for very high-end Regal systems. You are looking at $150,000 plus easily. Same thing with the Rock Ultra, because you don't want to buy a good sensor and then have no camera or a super cheap camera, so you have to get the right cameras to go with it. All of this good stuff. The biggest differentiation is the cost. And this is just the spec sheet too. What other people have told that if they've listened to me talk about it all the time, one of the biggest differentiators is that the DJI L3 system is just easier to use. And that's not just by saying like, oh, well, I know how to use complicated things, so it doesn't need to be easy. Except when it's easy to use, it gets used more, and there are fewer just dumb mistakes. When I say dumb mistakes, it's not like a safety thing. It's the whole idea that you plug in the DJI system and it just says, oh, hey, you didn't take your lens cap off. So you take your lens cap off and you fly it. Or, hey, your GPS system isn't connected. Push this button. Boom, you connect your GNSS base station. Everything works. It's such a harder, less user-friendly system, fewer quality of life systems on all of these other non-DJI sensors. They just take way more training, way more skill to operate, more time in the field, and that leads to it being more expensive, not just in terms of cost, but in terms of the manpower as well. So this is where we get into some of the uncomfortable truths about DJI that we've talked about before. DJI right now, especially with this L3, it is simply the best. It is the best sensor overall, better than any alternative. In the past, DJI has always had the best value, right? The L2, there wasn't a system that was anywhere near as good for the price, but if you were willing to spend $250,000, you could get a Regal Vux 1 based system, and it would be better quality just at an enormous price. DJI was kind of the value play, but now with this new system that it is competing with $250,000 systems at a $40-something thousand price tag, it is now competing on the actual best performance as well. That's the wrong key. So, like, a really uncomfortable truth too for systems, for non-DJI systems, the non-Chinese companies, they're not trying to compete on price and performance. They're only competing on regulation. The only reason that a lot of these other companies say, oh, buy us instead of a DJI system, is because they're trying to build up this fear that DJI is going to get banned, and they say like, oh, you should buy our system because DJI is going to be banned. And then there are certainly some restrictions in there, but it's just one of those kind of uncomfortable truths about all of this stuff. All right. Oh, I clicked away. Sorry, working on it. So given that, let's take just another couple of minutes and talk about DJI's regulatory environment. I'll make this relatively quick. First of all, I need to mention that this is politics, not law. People want this to be law where, oh, the text of the law says this, ergo that's what's going to happen. That's simply not the way politics has ever worked for that matter, but it is especially true today. Legal structure matters, but so do things like economics, political favoritism, all of that, trade wars, union things, what jobs are at stake. So let's talk about the current facts about DJI in China. Well, DJI is the market leader. 70 to 90% is the estimate of what commercial drones have. And as much as I love the surveying industry is not big enough in terms of a drone buyer to influence politics. But what is the fact that there are literally hundreds of thousands of small businesses, including content creators, wedding photographers, real estate photographers, videographers, cinematographers, other industries that use DJI drones. Those combined are what are going to have a little bit of a impact on policy that makes a full DJI drone ban a lot less likely. Should be noted, there are currently no federal or national restrictions on drones outside of Part 107. That is pretty strict in the law, that federal preemption takes the airspace. The only restrictions that can restrict anyone from buying flying DJI drones come from the FAA, and there aren't any. However, some entities do make their own rules, and these are enforced by contracts, not law. For example, the Texas Department of Transportation can and does say, if we hire you on this project, we ask that you don't use a DJI drone. If you use a DJI drone, we're not going to hire you for a contract. They can do that. They actually can't legally stop you from flying a DJI drone. For example, I could go fly a DJI drone over TxDOT projects, and as long as I am following the FAA rules of Part 107, the Texas Department of Transportation has no legal authority to tell me not to, but they have the power of the check. They can not sign me as a vendor if I don't follow their rules. So that is the way that other entities do it. The current NDAA, National Defense Authorization Act, requires an analysis of DJI by December, and this has some people predicting an imminent DJI ban. Now, that is where we now get back into that world of politics, that I don't think that is likely. The methodology by which any sort of DJI ban or restriction would happen would be through something that's called the FCC covered list, which has only been used historically, only ever been used historically to ban future products that aren't already approved. And in fact, that's part of the reason why DJI may have announced the L3 when they did, is because by announcing it, they can get it certified before any restriction, such that even if a restriction comes into play, they may still be able to sell the L3 and the M400. I'm not sure, that's speculation. So let's actually get into my very uncomfortable predictions. This is a weird one because you now get my personal estimations of the probability of different things happening. My estimation, having worked in drones in a highly politicized and weird regulatory environment for the last 11 years of my life, my prediction of the probability of the uncomfortable status quo. That means there's still Chinese-American trade tensions, but DJI drones are still federally legal, and some states will still not contractually let you do it. Probably about 60%. This is the most likely scenario in my mind, that DJI drones stay legal, but trade tensions remain, and it's a little bit of an uncomfortable status quo. This means that the National Defense Authorization Act kind of deadline in December will come and go, and nothing really will happen. That is my political prediction. Feel free to go crazy in the comments when we post this on a blog post if you disagree with that. The odds of a full and clear approval across the board, where DJI gets the green light to do anything no matter what, only 5%. That's Very unlikely in my mind. Trade tensions will remain both around drones and other industries as well. Obviously, semiconductors is a big one. Rare earth metals is a big one. The trade tensions and US-China relationship remains strained and is unlikely to change. So very unlikely to get a complete, full, clear approval. A temporary import ban via the FCC's covered list. This is where the DJI drones actually get banned. Future DJI drones get banned from import. That's possible. I put that at about 25% chance that for a certain period of time, future drones get banned. What this means in practice, if you want my personal opinion, probably should buy an L3. If you were considering getting an L3, get it sooner rather than later. The odds of a permanent import ban via the FCC covered list, 10%. That's an import ban. A permanent DJI gets put on that list and doesn't get allowed anymore. And future drones don't get allowed, but existing drones are still allowed. That is probably about 10%. And a retroactive ban on all DJI equipment currently in the United States, I view that as less than 5%. That would be very, very unprecedented. The FCC has never used that power via the FCC covered list. And again, politically, that would absolutely hose all kinds of small businesses, your real estate agents, your videographers, your wedding photographers, that sort of stuff. It would screw them, and that is a politically bad move, which is why that's the main reason I don't think that's going to happen. We talked about it before. Why aren't there more US-made drones? Well, there are. Most US-made drone manufacturers are focusing on military applications. Our headquarters is actually right across the street from a defense contractor named Anduril. They make such cool drones, and they are military drones. They are big. They don't follow the rules. They are world-class. They are better than anything else in the world, but they are not commercial drones. They target military and law enforcement. Fun fact, we actually know their security team really well because we obviously test a lot of drones here when we do all of these testing. And every time, because we are literally across the street from a defense contractor, they show up in SUVs with big scary people to say, why are you flying drones near us? And we have to tell them that we've been here for 10 years and that it's actually fine. Anyway, that's not relevant. So let's start wrapping things up. Should you buy a DJI L3? Yes, you actually probably should. It is the best drone LiDAR system available by a wide margin. There is that little asterisk on it. At any price, at this price point, it's just the best by a lot. There's nothing close. It beats the pants off of systems that are 10 times as expensive as it. So unless expressly forbidden by your clients, the L3 is the best. It is the new gold standard in LiDAR systems. Let's keep going here for a second. So here are a couple of other things. If you have a DJI L1 currently, yeah, you should probably consider upgrading. If you have an L2, I would put that in the wait and see side. If you want to stay on the cutting edge, yeah, absolutely do it. But the L2 is still a very good system. I don't think you necessarily need to if you're flying in an L2 system. If you're flying in another, like a Rock Robotics, like an R2 or even an R3 or something like that, then you should really consider upgrading. The L3 is massively better than any Livox or Hesai system, any of the other 905 nanometer lasers. And if you currently have one of those $100,000, $200,000 systems, yeah, you probably don't need to upgrade. It's not worth the additional cost. Yes, the L3 will be much easier to use. So unless you were looking to scale your system, buy it. But it's not enough of an upgrade over existing Regal systems that you need to purchase it. So let's go ahead and wrap this up, and then I'll try and answer all of the questions in there as much as I could. Final reminder, purpose of drones is better, faster, cheaper. Drone technology implemented is better than alternatives. It is faster than alternatives, and it is cheaper. It used to just be faster and cheaper, and now as technology has evolved, it is better than alternative surveying methods too. And of course, work with Aerotas. We get you good stuff. We're your partner on all of this. As a last thing, because the L3 is so new, we do not have exact information about pricing and availability. If you want information about pricing and availability of the L3, scan this QR code or go to aerotas.com/DJI L3. I will dump a link in, hang on a second. I pushed a button that I wasn't supposed to. There we go. Put a link in the chat right there so that you can click this, sign up, and we will send you updated information. There's also a little toggle too. If you just want pricing and information on that, you can click on that. We'll send that up to you, and we're not going to, bug you or sell you all kinds of other crazy stuff too. But this is what gets you then access to when we finally get our hands on it. We will do all sorts of reviews, tests, data, full review, and of course, as we often do, new customers do get $500 off their first project if you sign up for us. All right, let's go here. Do some rapid fire questions. What are some of the processing options for LiDAR data besides DJI Terra? DJI Terra is going to be your only option for the first step of initial processing, which merely creates the point cloud. You can integrate a lot of other data into that with customized GNSS post-processing, as well as once you have that LiDAR point cloud and the trajectory data, you can bring that into things like TerraScan, TerraMatch, Global Mapper, and start doing all of your drafting there. The full LiDAR processing workflow, I will refer you to some of our previous webinars available on our YouTube page, on our blog page. We do a lot of information about all of the software workflow there. Another person said, we recently got an Inspired Flight 800 Tomcat with the TrueView 540. It is very hard to fly due to each part of software being a different company. The integration sucks, and we switched to an X500. Yeah, that checks out, and that's the story that I've heard a lot. For what it's worth, TrueView, I've never seen them deliver bad quality data, but the integration sucks. It's very hard to fly, and people just wind up not using it more. It's the main reason why we love DJI. Another client has an M400 arriving later today. If a ban of DJI drones happens, would that apply to the L3 sensor itself? Absolutely nobody knows. Right now, the language of most contracts is not written by technical people, it's written by politicians, so it doesn't always make the most sense. Most of it is around the manufacturer of record for the drone itself. There are some companies trying to play cute with it, that like getting around the technicalities while completely violating the spirit of the law. You're trying to predict the rules, and unfortunately that's a weird game, and I don't think I can do it, or can do it accurately. Will the L3 system be more user-friendly than the L2 system? I bet it's comparable. I bet it's virtually an identical software that will be the same level of ease of use, similar systems. Let's see. Those of us in academic settings are forbidden from using DJI on federally funded research projects, so no L3 unless you can fund from a different source. Yeah, that's tricky. Can't help you with that one. Let's see, DJI Terra alternatives for LiDAR processing that doesn't have access to foreign software. You know what? That's a really complicated one. Again, I'll have to refer you to some of my processing webinars where I go much more in depth. How well will the LiDAR L3 or L2 do in high grass or matted ground vegetation? That is the hardest thing for any aerial mapping scenario, is dense matted grass. The L3 is likely to do better. This is one that they don't actually say, is when you have a LiDAR point that gives multiple returns, what is the minimum distance between returns? For example, if you have dense grass that is, call it, half a foot thick or something, will it only get one return, or is it enough that you can get 5 returns just in that half foot of grass? We don't actually know yet. The more that I forget exactly what the name of that particular metric is called, the basically minimum gap between points. I have a hunch that that's going to be pretty darn good on the L3 as part of that newer, more powerful laser with more returns, but we'll have to see for sure. But grass is always the hardest one to do. Photogrammetry capabilities versus P1 or M4E. The dual wider cameras result in capturing more or less overlap. The dual cameras will be better than the M4E, but not quite as good as the P1. The P1 is a full frame sensor, which means I talk about the physics of that underlying lens and image sensor. P1 has a bigger lens, bigger image sensor, better resolution per pixel, better feature identification from a pure photogrammetry standpoint. But overall, I think my favorite recommendation for that class is going to be that the L3 is the best when it comes out. and we will recommend it over the P1 because, again, that blended LiDAR workflow works. Okay, thank you so much. I appreciate it. It is now the top of the hour. I've taken up a full hour of your time. Please do sign up here so we have your information. Thank you so much for joining me. I look forward to processing all of your LiDAR data. I hope this answered questions. And if you still want to chat, you can even send me an email. My personal email address is just logan@aerotas.com. So with that, I will let everyone get on with your day. Have a happy Friday, a great rest of the week, and I will talk to everyone again when I see you next. Thanks.